I'm also going to say, just because we had this conversation yesterday, if you are legitimately interested in changing classes, I know at least one person changed yesterday.
Oh, really?
Okay, yeah. Contact your guidance counselor if you're legitimately interested in changing. If we're just venting and hypothesizing, that's fine. Totally fine, and I get that.
What's hypothesizing?
Estimating.
Right, so we still keep thinking
It's the same stuff, but in an entirely different order.
And you can use formulas, right?
I don't think so.
It's just slower?
Yes, significantly. Yes.
I need that.
But it's not, you don't get the college credit.
Oh, yeah, I need that.
So that's the difference. It's slower. You can use your calculators, but you don't get the IU credit. So it's a matter of what you're interested in.
Is this the 3.4 difference?
3.4 for the first like 2 slides. Yeah, 2 slides. Okay. I was just gonna say I know of one person that dropped from a DC class today because my friend in the regular pre-cal asked me if it was one of mine, and I said nope. So it is still possible. You can still change if you want to. I'm not saying you need to. I'm not saying you have to. I'm just saying it's an option for you if you are genuinely freaking out. What? And I get a second prep period. Okay. I'm just saying it's not going to happen. But if it did, I could deal with it. It's happened before. All right. I have had classes as small as 8 people. So we're going to do this. This is using that difference quotient, which again we have done, just didn't quite look like this. That is the wrong button. There we go. So we're going to do our f of x plus h, and our f of x is 4x plus 3. So we're putting this as a fraction, and I'm just going to put my f of, so 4 times x plus h, substituting that in place of the x. Yes, this is 3.4 for the first 2 slides. That's okay. I'm always happy to say it more than one time. Minus f of x, which is 4x plus 3. 4. This is 3.4 for the first 2 slides. And I'm just doing this as a substitution. I'm just doing it all kind of at the same time instead of breaking it up into pieces.
Oh, okay.
The numbers came from my f of x function over here.
Okay.
Just because if one person has the question, I guarantee you someone else has it, and you're just the only one brave enough to say it out loud. So then what we're going to do is we're going to simplify as much as possible. So we have a bunch of distributing to do here. I need to distribute my 4, and I need to distribute my minus sign. I'm going to go this way. So we're going to have 4x. Let's not whistle while I'm teaching, please. Thank you. Plus h. I didn't call out any names. I just said let's not whistle. Minus 4x minus 3. I skipped the 3. There we go. All over h. So I just did my distribution. Okay, that says plus 3, not a weird b. Fixing it because that handwriting looked awful. Okay. So we're going to combine some like terms up here. What do we get in our numerator? 4h. What's in our denominator? So what's our solution here? 4. So all of that for 4. Yes, dears.
So
So I did f of x plus h. Our f of x is here. So we're substituting x plus h in place of the x. Huh? Because we have x plus h is going in place of the x, yes? Going in place of the x. X plus h goes in place of the x. Okay? From our function rule. So we're using the same function. It's very much like the ones we did yesterday where we did like f of a, f of h, f of a plus h, f of 3a, you know, all that jazz. Oh, good. Then you really like what we're doing next week. Oh. Yes, Beverly. The difference is, the reason they say when h does not equal 0 is because can we divide by 0? No. So they just put that there because as long as h isn't 0, this works. All right. Same vibe, but this time it's got an x squared. So it'll say simplify, like they have this on the homework. It says simplify the difference quotient, and then it gives us this piece. It's the same difference quotient, just a different f of x function. F of x is 3x squared plus 2. So we're using our new f of x, but it's the same difference quotient. So same process. I'm going to do f of x plus h. So I'm going to substitute x plus h inside of the x. So we're going to have 3, and in place of the x, we put our x plus h squared plus 2. Then we're going to subtract f of x just as it is. 3x squared plus 2, and it's all over h. Okay, let's simplify this. And if you need to do it in 2 steps, we absolutely can. We can leave the 3 out front and do our x plus h squared. X squared plus 2xh. We okay, guys? As I say, if you got a question, you can ask me. Because right now, it doesn't sound like a question, and it's very loud. So I can hear your conversation over here. Okay, then we can talk later or quieter. Plus 2 minus 3x squared minus 2. It's all over h. So this one gets real long. I heard a wait. Is there a question with the wait or just needing time? Totally fine. What are we going to do next? Distribute the 3. If you want to do that all in one step and just wind up directly from here down here, that's totally fine. You do not have to write out that first step. We're getting our 3x squared plus 6xh plus 3h squared plus 2 minus 3x squared minus 2 all over h. Whew. Now it'll start getting shorter. Yeah, because the 3x squareds, those guys cancel out. So we're going to have our 6xh and what else is on top? 3h squared over h. So what do we have left over? 6x, that's not an x, there we go, plus 3h, because one of the h's cancels out. Or you can write it, just because this is the way the book has it for some reason in answer keys, as 3 to x plus h. I don't know why they factored it, but they did. I'm 100% okay with both of these. Okay? And even on my answer keys that I have for the homework, I've written both just in case you like that one. Okay? So that's the difference quotient stuff. When it says it in the homework, I saw that and I was like, ooh, y'all gonna get scared if we see that and we don't talk about it. Yes, dear. No, 191 is what we're about to start. So that's the homework for today, Monday, Tuesday, and I think actually Wednesday as well. Like, we about to take a whole long time on 3-5. Graphing! It does take a lot of paper. Luckily, I have many, many copy machines that I can make you papers for. It does. So we're going to talk about graphs of functions. And today is like the first time we're not going to actually do tons of graphing. But all, like next week, Monday, Tuesday, Wednesday, we're going to be graphing. Graphing. But also, we have like graph paper that I will give you guys. Like, you don't have to have graph paper, but I will give you graph paper. So we're first things first going to talk about whether we have even functions or odd functions. Thank you. Told you I would 100% forget. So even functions have y-axis symmetry. We've talked about that before. Odd functions have origin symmetry. We don't have to do separate tests for both of them. You can do it in one test. Last time when we were testing symmetry, we would test our x-axis symmetry, we would test our y-axis symmetry, we would test our origin symmetry. We can do one test to see. You can do the substitute in negative x. If the function is the same, it's even. If the function is the opposite, it's odd. And if it's anything else, it's neither. So our only options are even, odd, neither. Okay? So we're going to test today if functions are even, odd, or neither. I'll give you guys enough time to write this down. And we're going to find whether functions are even, odd, or neither from equations. That's going to be our next piece. So we're going to substitute in negative x for x, just like we did like f of h, f of x, that kind of stuff. We ready?
Yes.
Okay. I heard a couple of waits, a couple of no's. I know when my coffee makes weird noises. Totally fun. All right. Go fast. So you got things to do. All right, I'm gonna turn. 3, 2, 1.
Wait.
Boop.
Another 5 minutes.
I was gonna say, you on your phone anyway. I'm not listening to you. You ain't even holding the writing utensil. All right, so what we're gonna do is we're gonna determine if this function is even, odd, or neither. We're gonna substitute in the opposite of x in place of all the x's and see if it changes anything. So if it helps you to have it up here, an even function means my f of x is going to be exactly the same as f of minus x. They're exactly the same. If we have an odd function, my f of x or f of minus x equals the opposite. So negative f of x. So what we're going to do is we're going to come to these functions and we're going to substitute in f of minus x. We want to know how that's going to relate to the top function. So we're going to put minus x in x to the fourth and absolute value of the opposite of x. When I take a negative number to the fourth, yeah, it's going to be positive. So this is going to turn back into x to the fourth. Because a negative number to the power of 4, an even function, is always going to give you a positive answer. What about the absolute value of a negative number? It's going to be positive. So we're going to turn back into the absolute value of x. Since my f of minus x is exactly the same as this, that means this is an even function. It has y-axis symmetry. Since these are the same. Okay? Questions on this one? We're going to do the same kind of vibe on the next one. So we're going to take f of minus x on this next one. That's the opposite of x over the opposite of x squared plus 1. Substitute in the opposite of x every place you have an x. And then we're going to try and simplify this. Can I simplify the top at all? No. I'm going to make that a little less crooked. There we go. So that's still going to be the opposite of x. How about on the bottom? yeah, it's going to be our x squared plus 1. Because the opposite of x squared still gives me the same dang thing as x squared. So are these exactly the same? No. So we know it's definitely not even. What we want to then know, is this the same as the opposite of f of x? So let's take f of x and take the opposite of it. Opposite of x over x squared plus 1. When I simplify this, don't we get the opposite of x over x squared plus 1? So is it the exact same as the opposite of f of x? Yes. These are the same, which means this is odd. This has origin symmetry. Mm-hmm. It's origin symmetry. That word is symmetry. We have to check, we're checking even, odd, or neither. So we have to check 2 on this case. We don't have to do all 3. We're not looking for what's the kind of symmetry, just is it even or odd? If it's not even or odd, it's neither. There's not a test for neither.
When the negative,
Uh-huh.
why doesn't the plus 1 become minus 1?
Because we either change the top or the bottom. When we're multiplying a fraction, if because we can't do both because then it's a positive. So think if I had negative 2/3. It would either be negative 2 over 3 or 2 over negative 3. Not both, because then we're back to a positive. So you could put minus x squared minus 1 and factor out a negative 1, but you're making your life harder. Okay? Let's look at the bottom left one. We've got f of x equals x plus 6. So we're going to do f of the opposite of x. So opposite of x plus 6. Can I simplify anything there? No. Does it match exactly? No. So we know it's definitely not even. Then let's see if the opposite of f of x gives us that. So if we do the opposite of the f of x, I'm going to take my whole function, x plus 6, and make the opposite. So the opposite of f of x is what? Is that exactly the same? So is this even, odd, or neither? Neither. So when I took the opposite of x, it is not exactly the same when we simplified. When I did the opposite of the whole function, it still doesn't match. So it's neither one of them. One last one like this. And I know it's really cramped on the screen. I'll try not to do 4 on a screen again. In fact, I'm just going to make it do this, just so we can see it. I just zoomed it in so that we could see it, because I know it was way at the bottom and those in the back were having a hard time. So we're going to do our f of minus x. So we have 2 minus x cubed minus 6 times minus x. Lots of minuses here. Be careful. So our f of minus x is, so when we cube a negative number, we're going to wind up with that negative term. What about our minus 6 and our minus x? What are we going to have? Plus 6x. So do these two pieces match exactly?
No.
No. So we know it's not even. Then we have to check and see if it's odd.
Yes.
Let's check it. We need the opposite of f of x. So the opposite of 2x cubed minus 6x. When we simplify that, distribute that minus sign through, negative 2x cubed plus 6x, is this odd? Yes. These two match. So it's odd. It is the opposite of the original function. So if the opposite of x matches the original, it's even. If the opposite of x matches the opposite of the function, it's odd. If the opposite of x matches the original function, it's even. If the opposite of x matches the opposite of the function, it's odd. The opposite. Okay? We are heading in a different direction. We're headed away from even and odd for a little bit. Huh? Because we are going to start getting ourselves ready for graphing here. Because we're going to be graphing like most of next week. So we've got to talk about some discontinuities because not all of our functions are going to be continuous. We're just doing like a couple of sketches on these, not like proper graphs, so I'm not giving you a grid. So a discontinuous function could have a jump discontinuity, an infinite discontinuity, or a removable discontinuity. A jump discontinuity, so I'm just giving us kind of a graph, is going to be that we have some sort of function, maybe a parabola, and it stops, and then it jumps up. So it literally, my function went jump and continued on. We're going to be dealing with these kinds of cut up in piecewise functions a lot. So a jump discontinuity means literally it stopped and teleported somewhere else. Teleportation. An infinite discontinuity is called an asymptote. You've heard that before. We used those in Algebra 2, especially when we'd have like 1 over x kinds of functions, where it would be a literal wall. Wow, I'm bad at drawing straight lines, but close enough. Hush. Where our function comes and it gets really close. It gets really close, and then it goes further away. Asymptotes are walls that we can get really close to, but we can't go through. Can't go through a wall. My shoulders always get sore on asymptote days when I teach my Algebra 2 because I throw myself against my wall repeatedly because it's a wall. Can't go through it. I can get real close to it, but I can't go through it. Our last kind of discontinuity is a hole or a removable discontinuity. That's where we're going to have something, let me get a different color here. Or maybe we have a cubic this time, where we're going along, it gets a hole, and it continues on. And it could even have a point somewhere else, or just that one point. But that would be a removable discontinuity. It's a hole. Literally, somebody stabbed a hole in my line. And again, when I teach my Algebra 2 kids about that, I have them literally stab the paper for a few times. Because you're punching a hole. if it helps you, stab the hole. Do it. Totally fine. Okay. So we're gonna practice with those for putting it back. We're gonna practice with those on a sketch. Couple of times. Before I give you the last page of things to write. It'll be the same first page that we do on Monday, but yes, dear. Say it a little louder. I can't hear you over the conversation.
Not where you stop, but like the other one.
The removable. Oh, so that's a removable discontinuity. It's just that I punched a hole in the line and there's someplace else that works. So it's a point up there. Okay. We're gonna do a couple more sketches. We are gonna sketch a function with some discontinuities. If you want graph paper, I can give you graphs, or you can sketch them. Does anybody want a graph? Yeah. Okay, I'll pass them out. It's like totally fine. I have lots. Let's pass them out. Let's see, we're gonna do 2, so I'll give you a few. Some of them are numbered, some of them are not. They all work on the ones that are numbered anyway. So I'm gonna pass them out for everybody. If you don't use them, that's fine, but I'm gonna ask you to put them on my desk when you leave because my algebra kiddos are testing. We're gonna do 2 sketches, so I'm passing out 8 graphs, or 2 graphs to each of you, I think. I don't know. Y'all know I'm not great at counting sometimes. That is an infinite at -4, a jump at x equals 3, and a removable discontinuity at x equals 5. So if you want graphs, there should be some on your table. I'm gonna put my little bucket right there. So when we're looking for an infinite jump at x equals -4, that means we have an asymptote right here. Which I never...
How many graphs are we gonna need?
We are doing 2 sketches. These are the only 2 sketches right here. So just 2. Just the graphs stick together, so when in doubt, I always tend to lean towards more graphs. So we have an asymptote where x equals -4. Which means we're going to have a wall over here at -4. 1, 2, 3, 4. There we go, -4. Boom. So whatever's happening to the left of my wall, let me get a different color. I'll go gray. It's going to get real close to my asymptote. It doesn't matter if it's going up or down. I don't care. It's a sketch. We don't have any information about that. When we're on the other side of our asymptote, it's going to come either back up or down. It doesn't matter which way it comes from until we get to 3. In which case, it's going to stop and teleport somewhere else. I don't care where it teleports to. I'm going to go down just because I'm running out of space. And then we have a removable discontinuity at 5. So at 5, I'm going to draw another hole where someone has stabbed my line and moved the little hole punch hole elsewhere. Yeah, a jump at x equals 3. That would be a teleport. Yeah, that would be this guy right here, where it jumped from here down here. That's our teleport. And a removable discontinuity at x equals 5, that is where I stabbed a hole. Apparently I'm feeling a little violent. Physically punched a hole. I went to my line and I went, yeah, stab a hole. And then the hole punch fell down here. Can that dot be what? Random. I mean, it's you want it on the same vertical column, so it was still a function.
Does where is teleport have to be connected with where it's like where you stop the thing?
Since it didn't technically say that it was connected, no. But it's just one of those things. Then you're adding another discontinuity in. Yeah.
So basically, when it's like jumps,
Mm-hmm.
you add another hole,
Mm-hmm.
and then when it's removable, you add another.
The reason I have one closed and one open on my teleport. Ooh, that was not a laser pointer. Where's the laser pointer? There we go. It's so that it's still a function, so it still passes that vertical line test. If I had both of them closed, then when I would check for a function, if both of them were closed circles, it would no longer be a function. So one of them's got to be open, one of them's got to be closed, and that will depend on how our function rule is written when we get to doing them properly and not sketching. Ah! Yes, dear. What's up?
It doesn't matter where the 3 is on the y-axis.
No, we don't have any of that information. Yes, dear. Yep.
And then the dot can be random, right?
Yeah, as long as it's on the same vertical line. Because again, same thing, for it to be a function.
Why do you do this one right here?
Because this is an asymptote, I can't go through this wall. It's still
You
continuing.
have to do it twice.
Yep, it's approaching both sides. It depends on how our function rule is written, really. Again, it depends on the function rule. I just can't hit that asymptote. All right, so our next one is more simple. We've got a jump at x equals -3 and a removable at x equals 2. And this is going to be the last math thing that we do today. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4. And if you don't like anticipating it in the middle of a sketch, give yourself a line and then just like stab it. So we have a jump at x equals -3. We can draw our function however we want. We can do these all with lines. So at x equals -3, we could have a line that looked like that. And then it jumped down maybe here. And it went all the way up. And it's still a line. We have a removable discontinuity at 2. And it can continue. And maybe this time my point's above. I don't know. We don't have the information for what happens at that point. So this gives me my, let's do same color. My jump at x equals -3, that's this guy here, we teleported. And my removable at x equals 2, that's this guy here, up to here. Yes, dear. As long as we don't put like an arrow on this side, because if it goes over here, then we're no longer a function. It needs to still pass that vertical line test. We're still dealing with functions. Okay, so a little, but only something like we have arrows in the middle sometimes when we have an infinite, but like it still needs to be a function. Okay, so starting on Monday, We're gonna go through transformations again. This is also the first slide on Monday. So if we're done for like emotionally, like whatever, this is the first slide on Monday as well. And I'm gonna get out of the way for you. I'm like just like photobombing your picture here. Okay, so these are things you know. A, H, K, we've done them before. B may or may not be new for you. But we're gonna work with quadratics, we're gonna work with absolute value, we're gonna work with cubics, we're gonna work with square roots, we're gonna do rationals, and we're gonna do step functions. So that's kind of a preview of next week. It is the first picture on Monday as well. Ta-da! I put the thing up because y'all get grumpy if I don't. Yes, here. Yes, give me just 1 second. Okay. I just saw like 3 pictures being taken of the homework page. Antonio, it's also the same as on the yellow paper.
Can I get a pad for the quiz?
I have to come in for the quiz, yeah.
Yeah.